pleasure. Good morning, everyone. It's a great pleasure to have us join this webinar session today. The webinar is titled Statistical Analysis and its Interpretation for Beginners. The topic, statistical analysis, is such an exciting one, but it's kind of confusing and needs professional guidance for someone to find one's foothold in the field. Many thanks to Plus-Circle Community Health Advancement Organization for deeming it fit to bring this capacity strengthening session your way today. Without further ado, I would like to proceed to welcome our dear speaker and expert in the field, Dr. Karim Adeshola. I'll take our bio shortly. Please pay attention. Dr. Mrs. Karim Adeshola Omo Olawumi is a community health physician. She bagged a MBCHB degree from the Obafemi Awolowo University. She proceeded to have a Master of Public Health degree from the Central University of Nicaragua, South America, and she is a fellow of the West African College of Physicians, specializing in community health. Currently, Dr. Karim is a consultant at the Department of Community Health, Federal Medical Center, Owo, Ondo State, Nigeria. She is also a data manager for the Enable 1.5 project and the Lassa fever vaccine trial project. Dr. Karim is proficient in SPSS and R programming for data analysis, and she has successfully published more than 20 articles published in high impact factor peer-reviewed journals. And she's one of the top cited researchers in Nigeria. So, Dr. Karim, we're happy to have you on the call today. Please, you may proceed. And to everyone, you are welcome. Please, let's put down our question as the session progresses. It would be very inspiring and educative. If you have any question, you can make use of the chat box or you write it down so that we can take the comments and questions after the webinar. Thank you very much. Dr. Karim, over.
All right. Good morning, everyone. Okay. All right. I want to thank the organizer for this great opportunity. Permit me to share my screen. All right. Okay. Can start.
Okay. Please, your microphone is a bit low. Your volume is a bit low.
Oh, all right. Thank you. I will do this.
Okay.
Okay. All right, so let me start. Okay, good morning, everyone. Thank you once again. I want to appreciate the organizer for the opportunity. And this morning we're going to be talking about statistical analysis and their interpretation for beginners. We also want to switch over my video at this point because of network, so I can have a free flow. Okay. All right. So I'm sorry, I didn't know that the slide is towards the end. I'm trying to, okay. All right. So this is what we're talking about this morning. Okay. So I'll be discussing these the statistical analysis and their interpretation with using this outline. Talk about the learning objective. Please, can you confirm? Can you hear my
Yes.
Am I audible?
Can hear you clearly. Your screen
all right,
is.
thank you.
Thank you.
All right, thank you very much. So using this outline to discuss the statistical analysis, the learning objective is to describing the process involved in preparing data for analysis, and also to identify various methods of statistical analysis and their interpretation, apply relevant method in data analysis, and interpret the analyzed data and its implications for research. These are the learning objective for today's discussion. Okay, so briefly, I'm going to be laying a few foundation so that we can better understand what we're discussing this morning. So statistics is the branch of science that render various analytical techniques to deal with data. And the correct choice of statistical analysis method ensures that the right answers are provided to research questions. Okay, in this course of this introduction, you will notice that some word popped out: statistics and data. So data are measurements or observations that are collected as a source of information. When we are talking about statistical analysis, it's described as a process, can be described as a process of consolidating and analyzing distinct samples of data to either diverge or identify patterns or trends, or to anticipate future events so as to make appropriate decision. We want to ask, why do we need to use statistics in research? Yes, the reason it helps to measure and explain events or activities, to examine relationship, make predictions, test hypotheses, present information, make comparisons, to find similarities and differences, and also to draw conclusions. We will still be talking more about each of the points I mentioned now. Like I've already talked about this earlier, as part of the definition of terms, statistical analysis, and what data stands for. Okay. All right. Another thing that should be of interest, it's variable. Variable is the value that is measured or counted, or value of interest. We have different types of variable. I'm sure we'll have heard about independent, dependent, and variable. Independent variable, it causes changes in another. Why dependent variable? It's a variable that is affected or explained by another. I'll cite an example. Okay, for variable here we have sex. It's a type of the form of the marital status, religion. Those are variable as depicted in this slide. But like I earlier said, I was I said I'm going to give an example of what independent and dependent variable means. So, for example, we say use of face masks to prevent COVID-19. Here, like use of face masks, it's causing a change in another. When you use of face masks, then it's going to prevent COVID-19. So that's the use of face masks. It's an independent variable. Why the COVID-19? It's the dependent variable in this example I just cited. Okay, the COVID-19, it's been affected or explained by another variable by the use of face masks. Okay, so the example of variables here, like I earlier mentioned, age, sex, education, and take for example this case, Silifa Sanusi, the age 45, the sex here is already coded, it's already labeled. We have it's being represented here as 2, which I assume it's female. And then the education here is 1, probably probably went to university. So that's a way to code and recode when we are presenting our data, which I will later explain the cause of this presentation. So we have different types of data. We have the qualitative and quantitative. Okay, the type of data, it's one of the determinants in choosing the appropriate statistical analysis. So the qualitative and quantitative can also be further divided into using we can use them how they are grouped. We can here have the nominal, ordinal. For quantitative, they can be grouped into discrete and continuous. Someone will ask me that, oh, the nominal and ordinal, it's also a type of a scale of example of a scale of measurements. So for nominal, the nominal cannot be arranged. The nominal cannot be arranged in any particular order. Unlike ordinal, that can be arranged in order. An example of a nominal example, the common and the one that comes to mind readily, which I'll still show. It's an example. It's sex, where we have male or female, or ethnicity, Yoruba, Hausa, Igbo. So that one, you cannot arrange it in any particular order. For ordinal, which can be arranged in a particular order, where we're talking about severity of diseases, where we have mild, moderate, and severe. Or we can also Likert scale, when we talked about strongly agree, agree, neutral, disagree, some strongly disagree. So those ones are arranged, and this one is arranged in a particular order. We're talking about this discrete and continuous, very continuous type of quantitative data. Discrete deals with it involves integer, where we have 1, 2, 3, and then the continuous. It's a type of data that can take any value within a finite and an infinite interval. Okay, so that's the discrete example. We talked about parity for those in the medical field. Number of patients, we can't have 1.5 or 1.5 number of patients, either 1 or 2 patients on admission. Okay, number of surgical operations. Okay, and then for continuous type of data, example, it's when you're talking about blood pressure, yes, and then some sample results. Okay, like I mentioned, okay, the scale, another way of classifying the quantitative using the scale of measurements include interval, interval and ratio. So in interval, the measures the difference between measurements, but there's no true zero for interval measurement. The example that a common example that they use its temperature in Fahrenheit. While for ratio, that's a true zero exists in the ratio. We have the height, the age. If we're not talking about age as at last birthday, so that's the example for ratio. Okay, so these are the example I've cited. I've mentioned it earlier, so I'll just jump. So, to research methods, you have different different research methods: qualitative method, quantitative methods, and the mixed method. And here, each of them, it's trying to vie for the position of them being the best out of all. So, the research the quantitative for quantitative research method approaches, like mentioned, quantitative in nature, while qualitative, the approach is the same, but methodology and then type data collection for its research methods are different. Okay, for the mixed method, let me quickly talk about mixed method design. That's where we have both quantitative and qualitative combined. So we can have a convergent design in at a time in mixed method design, such that we have you have your quantitative data collection and analysis. You have a qualitative data collection and analysis. You match the results and now interpret results. You now interpret results, compare between the quantitative and qualitative, and then the other type of mixed method design. Yeah, it's also it's an explanatory sequential design. We have it could be 2 phases or 3 phases. It's either you collect you have your quantitative data collection and analysis. You identify the results for follow-up. Then you do the qualitative data collection and analysis. That's for the 2-phase design, and also to now interpret your results and then tell how the qualitative explains the quantitative. Okay, and the 3-phase design, you can have your qualitative data collection before you now identify features for testing. This is usually used when you're trying to develop a new instrument or experimental activities. Then go ahead to have your quantitative data collection. You interpret your results on how quantitative improves the qualitative results. Okay. So in quantitative results, it deals with figures as depicted in this picture. Only 1 in 30 take free ice cream. And qualitative is about explanation, basically. So for qualitative data preparation and analysis, you need to get familiar with the data, visit research objective, develop a framework, identify patterns and collections. The 5 common methods of qualitative data analysis mentioned there, like I've wrote here, it's common method of qualitative. There are so many. Okay, it's depicted, seen in this slide. We'll talk about that. The qualitative data analysis software, we have different types. In Vivo, it's used commonly. We have Atlas T. And there's also for quantitative statistical software, the Excel, the SPSS, the Data R, and Python. Type of statistical analysis, we have the descriptive analysis and the inferential analysis. The descriptive analysis summarizes data. So it involves the collecting, interpreting, analyzing, and summarizing data, presenting them in form of charts, graphs, and tables. Rather than drawing conclusion, it simply makes the complex data easy to read and understand. So it involves processes such as tabulation, and there's need for us also to have a measure of central tendency where we calculate the mean, median, mode, and then also measure of dispersion or variance, in form of range, variation, and standard deviation to determine skewness of measurements, and then time series analysis. Okay, so in descriptive analysis, majorly it's just to have the frequency to summarize the data in form of frequency for discrete data sets mostly. And then we'll have a continuous variable once calculates the mean, median, depending on if the data is normally, and this will help to determine if the data is normally distributed or skewed. Okay, that's normally distribution for symmetrical data, symmetric data, and then for the skewed, it's when we have the data, it's asymmetric. I would still talk more about that shortly. So, and then I also want to calculate the measure of the dispersion. Inferential statistics, it focuses on drawing meaningful conclusions on the basis of the data analyzed, and it studies the relationship between different variables or make predictions from the whole population. It is used to test hypotheses and involves the use of sampling theory, various tests of significance, statistical control. So there are 2 approaches to inferential statistics. Can have the estimation approach or hypothesis testing. For estimation approach, the types involve, we have a point estimation and a confidence interval estimation. Okay. So in point estimation, it involves computation of a single measure from the sample to represent the population. Taking a part of the sample to represent the population. The confidence interval estimation involves a range of values computed from one sample. So a certain percentage, usually set at 95% of interval calculated from such sample, will contain the true true population value. That's for the confidence interval estimations, where you compute a range of values from a sample, and then you would assume that 95% interval calculated contains the true population value. Okay, like the hypothesis testing is just involves a reduction of research questions into 2 mutually exclusive category. A negative and a positive statement is made from these when the research question is reduced into 2 mutually exclusive category. So the structure of statistical analysis to determine what type of statistical analysis you want to carry out. There are questions you want to ask to determine what needs to be done based on the problem or specific objective of the study. You want to know if you want to summarize or describe data, then you're looking at the descriptive statistics. When you want to make comparison or determine relationship between variables, you're looking at differential statistics. All right. So this descriptive statistic, like I earlier mentioned, we can represent the data set using frequency table, and also calculate the central tendency and then the measure of dispersion too. So the descriptive statistics, the frequency is usually used for discrete data. In some instances, you can use it for continuous data sets where it's been recorded. And then the central tendencies, I'm talking about the minutes. Known as the arithmetic average, and used for normally distributed data. While the median, it's the middle value after you've arranged your data set in order. Then it's normally used in skewed data. The mode is the most frequently occurring value in the categorical data. Many of this dispersion, it's measuring the variation of data. You have the range, standard deviation, interquartile range distribution, a few. Okay, for descriptive statistics, when we want to summarize our data for continuous data, want to, like I mentioned, for quantitative, measure the standard mean and standard deviation for normally distributed data. For skewed data, we're looking at the median and range. And this can be presented, the graphical presentation, either in histogram, box plots, or scatter diagram. While for qualitative, like I mentioned, frequency for discrete variable. And then, of course, looking at the incidence and prevalence. So we want to summarize data as such using the frequency table, and can be presented also using bar chart or pie chart. This is an example of how to present categorical data in a frequency table. And then also the graphic presentation of data using bar charts. Different types of bar charts are depicted in this slide. For us, okay, this is an example of box and whisker plots and then scattered diagram. For inferential statistics, it's concerned with decision making. Like I mentioned, there are two approaches: estimation and hypothesis testing. I've explained this area, talking about different types of estimation, the point estimation and the confidence interval estimation. I've also explained this earlier, the hypothesis testing, which involves reduction of research questions into two mutually explicit criteria: a negative statement of no association between variable, and that's what null hypothesis is all about, and a positive statement of an association between two variables, talking about the alternate hypothesis. So hypothesis testing is a process of investigating the truth about an hypothesis. An hypothesis is just a statement about a phenomenon or a population that has not been verified. That's what an hypothesis means. So you have this statement that has not yet been verified, and you go ahead to test. If to test this statement, and then to verify there is need for hypothesis testing, where data is collected, there is need for us to collect this data based on the observation. And then the procedure ends up with the computation of what we know as what is known as the p-value. And the p-value is just the probability, it's the probability of a difference that you notice, that you observe arising purely by chance. And it's popularly set at 5%. So that's what a p-value represents. So it's probability of a difference arising purely by chance, and popularly set at 5%. So the significance relationship are determined by rejecting the null hypothesis and accepting the alternate hypothesis. Like I mentioned, null hypothesis is an hypothesis of no difference. Variable A is not equals to variable B. Alternate hypothesis is an hypothesis of a difference. That's variable A is equals to variable B. So you reject null hypothesis for computed statistics when the calculated, when you're calculated, it's greater than the critical value. The critical value is usually using the table, either chi-squared table, t-test table. That's where using your the degree of freedom and the p-value that is set to be determined. You use the table to look at the critical value for whatever data you statistics type of statistics you're using. So when what you calculated for that statistics, it's greater than the critical value, then you would reject null hypothesis, showing that there is a statistically significant association between these observations or these variables. Okay, for computer-generated statistics, when the probability it's less than 0.05, then you say, we now reject the null hypothesis. All right. So the errors in hypothesis testing, let me quickly talk about it. There are 4 possibilities when any kind of study is carried out to verify hypothesis. For hypothesis testing, you can have a truly positive results, like we have here. A test says, oh, this conclusion from a study, this is a true situation. Test says accept the null hypothesis, and here it's saying it's true. So you truly accept this is a true positive situation. The test says accept, but the true situation is false. So this is a type 2 error when the study fails to detect a difference. When it's actually a difference. Okay, so we can have a true negative result here where test says reject, and then the true situation is saying false. Okay, so and then the type 1 error, which is also known as the test of significance, which is set at 5%, and also known as the alpha error. That's this the type 1 error. I'll still talk more about this shortly. So just know there are 4 possibilities anytime an hypothesis is to be tested. So the p-value, like I mentioned earlier, is the probability of obtaining a value as extreme or more extreme than that found in a study, given that the null hypothesis is true. It's a measure of chance of incorrectly concluding that there is a significant result when it does not exist. So that's type 1 error, usually set at 5%. Okay. So hypothesis testing requires use of statistical analysis tests, t-test, chi-square test, depending on the type of data that we're trying, depending on the type of data. The p-value and confidence interval both used to test statistical significance, and then both lead to the same conclusion concerning significance. The key advantage of p-value is that its interpretation remains constant irrespective of the measure of association. Unlike confidence interval will give the direction and also will give how precise your result is. Okay, the precision is such that the narrower the confidence interval, the more reliable, the more precise is the results. The wider the confidence interval, the range that you got, the less reliable the results. So that's something about confidence interval. It talks about the precision, and unlike a p-value, the interpretation remains constant irrespective of a measure of association. Okay, and then for the confidence interval is interpreted as significant if the range of value exclude null value. Okay, the null value here is that in test of difference between 2 means, the null value is set at 0. For odd ratio, which measures strength of association between two qualitative values. The null value is set at 1. Okay. So in confidence interval, the null hypothesis must not be the null value must not be included in the results. Okay. Take for example, for a 2 by 2 table, or this when you have the odd ratio, and the result, the null value is 1. So your confidence interval, if you're looking at the results, must exclude 1. So it should start from probably 1.5 to what excluding 1. It has to exclude 1. So it shows that this confidence interval is statistically significant. Okay. Talking about that, it's also the need for us to understand degree of freedom here, because the degree of freedom is required also in hypothesis testing. Like I was talking about the critical value the other time. For you to determine the critical value of a statistical analysis, you need the degree of freedom. And the degree of freedom calculation, it's different for different. It's different depending on the type of statistics you are using. Okay. For the independent sample t-test, the calculation is n1 plus n2 minus 2, where n stands for sample size of group 1, n2 stands for sample size of group 2. Okay. For chi-square, it's rho minus 1, brackets, then column minus 1. Okay, so that's the calculation, or the formula for calculating degree of freedom, depending on the choice of on the choice of the statistical and the analysis you want to carry out. So it's also usually related to the number of parameters estimated independently from the sample. For measures of association, talking about strength of association, for qualitative variable, we use the odd ratio and then relative risk. So the odd ratio is a measure of strength of association between risk factor and an outcome. It's also known as cross product ratio. When we are talking about the 2 by 2 table, we have the AD over BC. So that's what odd ratio, and it's usually used in case control study. And then the derivation of odd ratio is based on 3 assumptions. That the disease being investigated must be relatively rare. Cases must be representative of those who have the diseases. The control must be representative of those without the diseases. Unlike the relative risk or risk ratio or incidence rates, is a ratio between incidence of disease among exposed and incidence among non-exposed, determined only from cohort study. Yes, so that's the relative risk. Correlation coefficient is used to test for the analysis, used to test the strength of association between two quantitative variables. Then we have our correlation coefficient. The R ranges from -1 to +1. And then for regression analysis, used to predict one variable from another. Okay, so that's we'll still talk more about that shortly. Okay, Dr. Falabi, you raised your hand.
Yes, Dr. Karim, thank you very much. So, I just felt to chime in at this point. Someone raised the question. The person shared it personally with me, and I felt you can react to this extensively before we continue. And the question is, where exactly do we start from when presenting the summary of the data, when summarizing data? What exactly should someone look out for? What variables are important to just describe, like descriptive statistics? What variables do we need to quickly conduct an analysis for, so that any other person could interpret the data and understand exactly what the summary of the data is like? So I just felt to chime that in so that you can respond to it. Thank you.
All right. Okay. So when summarizing the data, the frequency of the data is very key, and depending on the type of the type of study you're trying to carry out, like I mentioned, if it's going to be descriptive or inferential, the first thing is the socio-demographic, the frequency of what you're trying to present. It's key. That's where it will start from, to have a basis, to have an understanding of what you're trying to present. So if it's a comparative study too, yes, we want to first see to give the summary of what your objective is talking about initially, the social demographics, of your work, of your research, yes, of your study. That's first thing you want to present in a data. We'll still talk about it. It's a practice that we're going to look at the end of this study. So thank you. All right, and I believe I'll answer shortly. In case I've not answered, hopefully you will still see it during the course of the presentation. Okay. All right. So for the inferential statistics, we have the chi-square test, correlation analysis, regression analysis. The chi-square test is used to compare observed and expected frequency distribution. For correlation analysis, it's like I mentioned, degree of or strength of relationship between two variables. Regression analysis is to determine the relationship between two variables. Okay. So the different types of statistical analysis, the t-tests, if the variable, both t-test and ANOVA, they are both used when the interest is in comparing the means of groups. For t-test, when we have two groups, for analysis of variance, when we have more than two groups. But note, they are both used for comparing means. That means the data you're trying to analyze here must be continuous type of data. Okay, so when it's in two groups, you're talking about D. When it's more than two groups, you're talking about ANOVA. Okay, so the t-test, we have different types. We have the unpaired, that's before and after, and then we have the paired t-test, or the independent t-test when you're trying to compare between two groups. Okay, the ANOVA, it's a one-way. We have one-way ANOVA, and then it's also two-way ANOVA. For one-way ANOVA, that's when the difference between more than two groups with one variable outcome. Then you're comparing more than two groups with one variable outcome. For two-way ANOVA, also more than two groups with two variable outcome, and they are usually use this test when data is symmetrical. That's normally for normally distributed data. Okay, so the consideration before choosing an analytical method, like I mentioned, it depends on the design of the study. The cross-sectional, when talking about one group, cooperative cross-sectional. Talking about cross-sectional, it's like it's the simplest form of observational study, and it's like a snapshot when you're taking a snapshot of the population. So it's based on the single examination of the cross-section of the population at one point in time. For cross-sectional, I usually provide information about the prevalence, and then most useful, especially for when you have a chronic diseases. Talks about the distribution of the disease in a population rather than its etiology. It cannot establish causality. So, and then also it cannot establish time sequence. The difference between this cross-sectional and then the case control or the cohort is that those ones have a control group. The cross-sectional is like a snapshot. You go there and then you take whatever the information that's needed. So, and then the case control and cohort, I've explained that earlier. Then also we have a randomized control trial and also meta-analysis.
Those of them who doesn't have serious.
Can we please mute our mic, please? Thank you.
Press mouse for me.
Okay.
So also, before we choose an analytical method, we also need to consider the objective of the study. All right. So the decision made in the rest of the research exercise depends on the objective of our study, the nature of the data collected. That's why we had that foundation where I talked about different types of data. Okay, the pattern of distribution of the data also is key. The parametric and non-parametric. The parametric assumed the data is normally distributed, unlike the non-parametric that assumed that the data is skewed. And then for parametric, central trend, the measure of central tendency, it's mean. For non-parametric, it's a median. And then the for non-parametric, usually what is used, it's based on ranks and counts, unlike parametric tests, where typically the data are could either be in form of ratio or interval. Okay. So also, when we would choosing analytical method that we're going to use, we also have to consider the sample size. Based on the objective, if the objective requires for the data to be summarized and described, you use the descriptive statistics. If the objective requires for inference to be made, you to think about inferential statistics. And if the objective requires for data to be classified or pattern determined, you use exploratory statistics. I've mentioned this, that the non-parametric is based on descriptive data, while parametric test can either be used continuous data, use continuous data ratio or interval. For data collection, data must have been collected before the analysis. Data can either be collected through primary sources or secondary sources. Primary sources, that's when you gather the information directly through interviews and surveys, while secondary sources, you pull information from existing resources. For data collection, in many instances, data are collected from a variety of sources using both quantitative and qualitative method. That's the least method. And then you have your data entry. That's where you manually enter or you export into a statistical software like we have here. So you have entered your data that's needed for data cleaning. And this is the process of amending or removing data in a database that is incorrect, incomplete, improperly formatted, or duplicated data, and inconsistency that may prevent accurate analysis. Okay, so here that is showing, I used the SPSS to explain this data organization, and also for the practice, we're going to be trying our hands on SPSS. Statistical app, okay, or package. So here you would, for data cleaning in SPSS, we'll show that later. By the time you right click on any of these variables, when you sort ascending and sort descending, it will show you some missing variables, duplicated data, data with inconsistency, incorrect data. It will just bring it out for you to see. Okay, and I advise also when you're using SPSS, it's better because here we have some serial number that comes with the data package, the SPSS package. We'll always advise that you also enter your serial number, and the reason is because if there are many missing variables, and we'll be able to track the missing variable in any, probably if it's if you are using a hard copy or questionnaire, you can always go back and look at it so that you can correct appropriately. Okay, so that's for data organization. And then also we have data manipulation. That's where you record creating new variables from the old variable. You record the quantitative variable into categorical. Take, for example, the age. When you have the age in the continuous, the age 13, 14, 15, 16, 17, like that. Let me say it here. Okay, all right. So this is the age. And then we have 45, 60, 55, and all that. So once you record, and they're going to group the age into 10-year age groups. So, or using the and whatever age group that you want to use. Adolescents, you are using the early, the middle, late, you can group as such. And also for BMI, you can also manipulate your data as such. Okay, so we now check published literature to find out what other authors have used, and then quantitative variable versus categories, quality of life score, or percentage with good quality of life. So we can manipulate our data and record it depending on what we want on SPSS or any of these data statistical data analysis and package, okay, that or how. So the data manipulation also, the recoding a category variable into another categorical variable with fewer category is required. So if the number of participants in the category is very small, and if the variable will be used for statistical tests, so that it's meant for us to record. All right, so, talking about that, most times when we enter data, either in Excel or in SPSS, some want to enter this data as strings. For SPSS, when you want to manipulate or do other analysis using SPSS, you notice that it will not be able to analyze anything in strings form. Rather doing the bivariate or multivariate, you have to manipulate or encode the data back into into numbers, into numeric. So for that's talking about SPSS. And at times when we export from Excel, most times some of us will enter using strings or any other thing that you want to do on that data apart from the descriptive. It will give you the frequency when you run it on SPSS. But any further analysis that you want to carry out, it will not respond. It will just give an error or give you a wrong result. So you have to recode such a string into numeric. Even for when you're asking for people's opinion, you need to also group such and then recode into numeric. That's talking about SPSS. So data analysis involves manipulating data sets to identify pattern, trends, relationship using statistical technique, and also the use of computer software to automate this process and reduce the likelihood of human error in statistical analysis process. I'm talking about human error. Most times when some people are using this statistical the computer software, they will be looking at it and there is no missing value here. Checked because they were checking manually, and by the time you start ascending and descending, you notice all this missing value, incorrect value, and all that has to be changed. So that's the beauty about the computer software. Then the data presentation. Okay, from that question that was asked, the first thing you needed to present when you're summarizing the data, I think this explains that. So the one is showing the prevalence of family planning uptake among respondents. That's why I said depending on what you're trying to present. But the first thing is social demographics. You want to know the age, the sex, and all of the respondents. And that's first thing, but some will not request for that. Some college for exams, they will say, no, I don't want that, I want this, I want that. But the first thing you want to see is just a summary, the frequency of what you are presenting before you now go further to do probably bivariate analysis, multivariate analysis. So once you see the frequency as shown here, using tables, charts, graph, test, or process. Okay, so now we move to data interpretation. The last step is data interpretation. It provides conclusive results regarding the purpose of the analysis. The results after analysis can be presented and interpreted in form of charts, reports, scorecards, dashboards to make it simple and accessible. Now for the practice. Yes, this is the pattern, but looking forward to it. For the practice, research, the topic is prevalence of exclusive breastfeeding among mothers in a semi-urban Nigerian community, a cross-sectional study. Don't mind the topic title, just let's take it like that. Okay, so the objective is to assess the prevalence of exclusive breastfeeding in a semi-urban Nigerian community, to determine the pattern of exclusive breastfeeding among mothers in a semi-urban Nigeria community. Okay, so this it's my topic and these are the objectives. So my research question is there a difference in the pattern of exclusive breastfeeding in semi-urban area, in semi-urban Nigerian community? Then I will talk about my null hypothesis. There's no difference in pattern of exclusive breastfeeding among mothers. Then the alternate is saying there is a difference in the pattern of exclusive breastfeeding among the mothers. My level of significance, I want to put it at 5%, which is 0.0. That's the p-value. And then the choice of tests and statistics here, based on my objective, I'm looking at the use of to depict or present this result. I'm looking at using frequency, okay, and then I'm also looking at using chi-square test because I'm talking about proportion here. Yes, because it's about the pattern of exclusive breastfeeding among mothers. There are for here it's like I'm using a discrete data set. I'm not using any continuous data set or continuous variable here. Okay, so it's I'm looking at some chi-square. That's the choice of the test statistics I want to use based on my objective and then the nature of my data, which we'll see shortly. Okay, so please let's quickly look at this video. This is the SPSS package. We have two views to it. We have the data view and the screen recording and the variable view. So my data, it's already, I've entered my data into the SPSS. Okay, I've entered the data into SPSS as seen here. We first want to enter it into the variable view. You would have to write the name. You can see the serial number, you label it appropriately. And then the age also, you will notice that the type of data here, it's numeric. And then also the marital status of my respondent is it's air. And those are breastfed exclusively in the last 6 months. I already noted them and then also written the label in full. Okay. Here the value is given for marital status. Here we have one for single. I'm sorry, I screen recorded, so still doing this here. So please bear with me. All right. So the single, married, widowed, cohabiting, separated. And for exclusive, did you feed your baby with breast milk only in the last 6 months? You have yes, 1, no, 2. Okay. So we now come to the data view here. So when you click the data view to show you the summary of what you have entered in the variable view. Okay, so the exclusively breastfed in the last 6 months, yes or no, the marital status, it's also there. And then the age of my respondents are also depicted in this column. So I want to check the frequency. I'll click the descriptive statistics, sorry, come back. Okay, I'll click the analysis, come to descriptive statistics, and then go to frequency. As you can see on this screen, frequency, and to give me this box, I want to check for I want to check the frequency of those that are exclusively breastfed in the last 6 months. Because it's a discrete data, I don't need the mean, I don't need the median. Okay, so I just decided to open that so that you see what it's inside those small bars. So I go back to the frequency format, should be in ascending order. Okay, usually I don't use the chart on SPSS. I usually go to Excel to for my data, the charts. If I want to use any of the charts, I repeat it in the SPSS. Okay, so by the time you click OK to find the frequency, it will bring you to an output window here where your results will be depicted. Here, did you feed your baby with breast milk only in the last 6 months? You can see the yes, 28 people said yes, and the percentage is 22.8. 298 said no. You have the percentage at 77.2. Okay, so it's depicted in bar chart here. Okay, since it's all right, so all right. So that's the first objective, to know the prevalence. I want to now answer the second objective, looking at the marital status of the mothers. We have the single, the married, and then we have cohabiting, widowed, and divorced. You notice that for this marital status, the number of values there are more. The married, single, cohabiting, and what have you. So if I'm going to analyze and check for the chi-square and to know if there's an association between these two, you notice that it's going to be like 6x2 table. So there's need for me to record. So for you to calculate the to get the chi-square, you need to use this cross tab. When you click on it, analyze. Let me go back quickly, since it's a screen record. It's like, I'm sorry. Okay, so you go to descriptive statistics, you click on cross tab there. It gives you this box. All right, so your outcome variable will be on the column, and then your independent variable will be on the row, because based on the objective that you're trying to look out for. So the chi-square, you click on the chi-square, and then you continue. The cell once observed, and then the percentage you want it to enroll, you click continue. I'm just the roll order also. I want it in ascending order. This bootstraps is for samples that are more than 1,000 and above. So since my samples my sample is not up to 1,000, I'm not going to use that. So you click OK, and then you have this result in your output view. Okay, so here I can see, like I said, it's like a 5x2 table. And the Pearson chi-square result here, it's 5.42, and then the p-value is 0.242. But mind you, we have 70% have expected count less than 5%. So when you have more than 20% of the expected cell count less than 5%, we're going to be reporting Fisher's exact for 2x2. But when you have more than, please let me post this. When you have more than, when it's not 2x2 table, we have 5x2 or thereabout, we're going to be reporting likelihood ratio. And when reporting Fisher's exact, you would not include the value in the chi-square row. You just write out the p-value alone when you're reporting Fisher's exact. So because of the many the values in this marital status, like more than 2, I want to recode. That's what this one is showing. I want to recode my marital status. I want to recode it into 2, married and others. Okay, so you just create another role in your variable view. You put the name. I'm writing the label, and the recorded marital status. And also, now add values to it. 1 is for married. The value 1 is for, and then the label it as married, and add, and wait on. Yes, adding that. Then 2 for others. Oh, sorry, 2 for others. I think the video was, I'm sorry. Is it me or somebody else is moving this? The video should be more than this. Oh, okay. I think it just went off on its own. Let me go back quickly to that. I think I'm taking too much of our time. All right.
Hello, Dr.
Okay.
Karen.
Yes, Liz.
Please, before you proceed, so someone is requesting that you please go over the likelihood ratio again. When should we use likelihood ratio, and when should we use the other ratios available?
All right. Okay. For likelihood ratio, when the results when the table, when it's not 2x2 table, probably you have 3x2. That's your outcome is 2, but your independent variable, you're having like 4, 5. And the more than 20% of the expected cell count is less than 5, then you will use likelihood ratio. But for 2x2 table, when the expected when more than 20% of the expected cell count is less than 5 for 2 by 2 table, you're going to use Fisher's exact test and not Pearson chi-square. So when you now have less than equals 20% of the expected cell count less than 5, of course, you will use the Pearson chi-square value there. So that's the explanation for that. Okay, so you recorded the marital status into married or others. The screen recording jumped at a point, so I'm trying to locate that. Okay. All right. Let me just play this. So after I've recorded, I now run the cross tab again to check for the chi-square. And here we have married and others. Okay, you can see that the zero, okay, pause this. So the zero cell have expected count less than 5. So here I'm going to be using the Pearson chi-square. This is the chi-square 2.439, and this is the p-value of 0.118, which is greater than 0.05, which is my p-value, the set p-value. So these the marital status, the relationship, association between the marital status and exclusively breastfeeding babies, in the exclusive breastfeeding, it's known as statistically significant association between the two based on my results here. Okay, so that's what this table is depicting, and then we can move to the next slide. Okay. All right. So the summary starts in hypothesis testing. You have your research question, you have your objective, your research question. You state a null and alternate hypothesis. You state your level of significance. You choose your test statistics based on the design or the objective of your study, the sample size of your study, and also you can choose based on if your data is normally or normally distributed or skewed. So you choose test statistics based on this. When you have chosen your test statistics, you calculate degree of freedom for those that want to manually compute their data sets. The reason why you're calculating the degree of freedom is to be able to determine the critical value using the the statistical test table. If it's chi-square, you look for chi-square table. If it's t-test, you look for t-test table. If it's ANOVA, you look for the ANOVA table to be able to decide the critical value using your p-value that you've already set and the degree of freedom calculated. Then you now go ahead and calculate your own test statistics. After you're choosing the test statistics, you apply these test statistics to the data collected to calculate. So when your calculated is greater than the critical value, it shows that there is a statistically significant association between the two variables you're trying to test. And then you can reject your null hypothesis. Okay, but when your calculated is less than the when your calculated is less than the critical value, of course, you will fail to reject null hypothesis or you accept your alternate hypothesis. So you now evaluate confirm, like I already explained, and then make a decision to either accept or reject the null hypothesis. So in conclusion, statistical analysis involves how data will be recorded, organized, retrieved, and analyzed during the study. So researchers must identify variables to be measured and the instrument to be used before collection of data to ensure quality data. These are my bibliography, and thank you for your attention. Thank you, Nova.
Okay. Thank you very much, Dr. Karim, for the exciting session. Thank you very much. Dr. Lani, apologies. I had to chime in at that point so that she clarifies that at that end. She was speaking about the subject matter at that point and just felt if she could wrap up the clarification instead of coming back to it. Yes. So a few things before we take our questions. I'd like to reiterate or emphasize a few tips that Dr. Karim mentioned before we accommodate questions. So if you have questions, you may kindly use the chat box or raise your hand and would kindly allow you to speak when the time is right. Yes, so I wanted to say that, like she had mentioned earlier, the type of data is critical to the outcome, the type of analysis to conduct, whether to use chi-square, to use Pearson correlation coefficient, or any of the other methods is important. It's important that it answers the objectives of the study. Now, if, for example, we are looking for the prevalence of exclusive breastfeeding, or we are looking for exclusive breastfeeding, factors associated with exclusive breastfeeding. So that means the categorical variable, we need first of all categorical variable, those who exclusively breastfed and those who did not exclusively breastfeed. So exclusive breastfeeding rather, yes or no. So it is dichotomous already. It has two groups and it is clear. So the outcome of interest in a way influences what type of analysis we'll be doing. So if I am saying factors associated with exclusive breastfeeding, I should not do I should not do a test statistic that is using a mean comparison, Pearson correlation coefficient, or any of the t-tests and the rest. ANOVA would not be appropriate for it. So it calls for us to be able to distinguish when each of the test statistic would be appropriate and when they would not be appropriate. If we say we want to check for the factors associated with late coming among resident doctors, that means we definitely have two groups, our outcome variable in two groups. Those who come late, we can say arrival time, late or early. But that is after we have determined a cutoff, which we have validated using existing literature. So I just felt to bring that up. And secondly, for our sex, we know that even when we run descriptive analysis of sex, we can't, even when we run descriptive analysis for sex, after categorizing it into one for male or female or otherwise, as the case may be, we do not need to run mean or standard deviation and the rest for sex. Sex is either male, female, or maybe unclassified, as the case may be. So in instances where we have selected on SPSS, in instances where we have selected a measure of central tendency, maybe mean, standard deviation, mode, range, and the rest, even if it generates such a value on sex, we should not report it because you are either male or female or otherwise. So I just felt to bring that up. Okay, before we take Dr. Zacharias' question, someone is asking, am I correct? Okay, Dr. Zakaria, please hold on a bit. Let's take this question and then we'll accommodate yours. Thank you.
Okay, thank you very much. Hello, all of you. Have a great noon. Thank you very much, especially Dr. Adosela Karim, for your great explanation and concept for the statistical analysis concept. I'm Zakaria Abdul Ahmed. I'm doing a Master of Philosophy in Epidemiology and Public Health. So I have question related to about case control study. Dr. Adesela has explained it about what I say an odds ratio. As we know that odds ratio is when we compare about relationship between qualitative variable. For example, if I have two groups, exposed group and non-exposed group, So the final result, that outcome from the odds ratio, for example, if I get 1 and these two group, when I compare practically, clinically, that those exposed group have more, means the more than clinical symptoms than unexposed group. And odds ratio as result is theoretically as by hand calculation, and for result of 1, how can I interpret between the theory calculation and the practically clinically?
Okay, can I answer that?
Yes, please go ahead.
All right, thank you very much for the question. All right, so for odd ratio, when it's one indicates when you calculate, one indicates no association. When it's greater than 1, it's positive association, and that's risk factor, also known as risk factor. When it's less than 1, it's a negative association, and also known as protective association. All right, so that's for the theoretically. For practically, the odd ratio tells about the direction of the outcome. So depending on the odd ratio you get, if you are having 5, probably you calculate 5. As if I take for example association between cigarette smoking and lung cancer, and then you have your odd ratio after you've applied the appropriate test statistics. You have odd ratio of 5. So what the odd ratio is saying is that that's like 5 times likelihood of those that smoke smoke cigarettes to develop lung cancer. I'm just taking for example, all right. So that's for the practicality or the real life estimation of that odd ratio. So it talks about the direction, the number of times it's likely or unlikely to occur if you have negative or positive or what's called results. You get a positive or negative results in the odd ratio. I hope I've been able to answer your question. Thank you very much.
All right, thank you very much, Dr. Karim. Dr. Zakaria, I hope Dr. Karim answered your question. But in addition to that, I want to say that clinically speaking, level of significance actually may not, it may require, the statistical analysis findings may require clinical interpretation. Yes, because statistical results may not suffice in some contexts. So if you are a clinician, I believe you have more insights into the subject matter and can interpret the finding, the statistical results appropriately in that context. Yeah. So Dr. Zakaria, has your question been answered? Please confirm before we move to the next.
Yeah, thank you, ma'am. Thank you, ma'am.
Okay, great. All right. So the next question, okay, the person is asking, am I correct to conclude that SPSS can be used for analysis of all variable types, quantitative and qualitative alike, provided the variables are appropriately coded? Dr. Karim, over.
All right, thank you very much. Yes, yes, for quantitative or qualitative data, you can, as long as it's correctly coded, yes, you can use. But don't mix it up with the research methods. You know, we have quantitative research method and qualitative research method. Where for qualitative research method, the data collection there, you're using your interview, focus group discussion, and that one also has another statistical analysis package for that. So if you're not missing it up based on research methods, but you're using the question is based on the type of data, quantitative and qualitative. Yes, if it's appropriately coded and recorded, yes, you can use SPSS to analyze. Thank you. Over.
All right, thank you very much, Dr. Karim. Do we have any other question or anything that needs to be clarified? Okay, someone is saying, is it only NVivo and Atlas TI apps that are used for qualitative analysis, or are there other apps? That's question 1. Then question 2 from the same person. Is it okay to use tables, charts, graphs, etc. to present the data, or we stick to only one, e.g., either use graphs or charts all through for uniformity? And then 3, kindly throw more light on structure of statistical analysis. Over.
All right, thank you very much. There are other qualitative data analysis software apart from the Vivo and the Atlas. You have the CUDA, Transcendent, and others like that. So it's not only Vivo and Atlas T. Okay. For presentation of data, like I mentioned, it could either be in graph chart, table, or in prose. You cannot use the same. You cannot present using the same. You cannot using table and graph for the same what's called now summarization. You either use it in table, or you present it using a chart, or you present using proofs, but you cannot summarize the same data set or the same what's called objective or using that using table at the same time using data or proof. So you either use either of them to present your data summary. Okay, you said I should elaborate more on the structure of statistical analysis. Okay, like I mentioned, the choice of statistical analysis depends on the design of your research, the objective of the research, the sample size. Okay, so if you are talking about the objective of the study, you want to know, is it requiring you to summarize or describe? Then you're thinking of descriptive statistics. So if there's need for you to now make comparison or to determine a relationship between two variables, then you're looking at inferential statistics. So for the descriptive statistics, that's where you summarize the data sets using the frequency table for discrete value variables, yes or no, true or false. That one does not require you to calculate mean and median. Unlike your continuous variables, when you have numbers, then where you need to calculate the central tendency and measures of dispersion. Using mean, median, or standard deviation, interquartile range, or range, depending on if your data set is having outlier or not. So that's then when you now talking about comparison, we move to inferential statistics. That's where the inferential statistics talks about more about the hypothesis testing and then estimation, depending on the one you want to use. Like I mentioned, the hypothesis testing, the p-value, the result is the same. It speaks the same, or like the confidence interval estimation, where it talks about how reliable your results or your calculation is, right? So what for this structure of statistics, that's need for everyone for you to collect the data and then check collect your data, and then you would now apply these test statistics depending on your the objective of the design of your work. I hope I've been able to answer that question in summary. Thank you.
Okay, thank you very much, Dr. Karim. So the next question says, is it every quantitative research that have hypothesis to test? Must we always test an hypothesis for every study which we want to undertake?
My answer is an affirmative yes. Because every study you want to undertake, you're trying to have a statement. There's usually a statement about that phenomenon or the population. So the hypothesis testing is just for you to confirm, oh, is this statement correct or not? So yes, for every quantitative, for every test, yes, there's an hypothesis. As long as there's a research question, yes, then you need you know that you have your you have to write out the hypothesis, state the hypothesis, and then you go on from there. Thank you, Enova.
All right, ma'am. Please, can the measure of association between two variables be done using tools like Man-Whitney-U if it is an unskilled data? Can the measure of association between two variables be done using tools like Man-Whitney-U if it is an unskilled data?
Yes, Liz, thank you. I decided not to talk about the non-parametric test. I just like summarize the test. Yes, for every peer parametric test statistics, that's the non-parametric type. I've summarized what parametric and non-parametric entail. Especially take for example for paired t-test, the non-parametric component is the Wisconsin sign ranked test that can be used. Yes. So after you have considered all the what's called the parameters for the use of parametric and non-parametric, after you've decided that, oh, this data is not normally distributed, is asymmetrical, then you consider that for a peer test. ANOVA is as Wally's test for one way, and then for two-way we have the Friedman's test. So the peer test. It's Man-Whitney-U test. That's the non-parametric component. Components with the parametric test. I hope I've been able to answer that. Thank you, and over.
All right, ma'am. Could you please elucidate on the exploratory analysis in the determination of patterns? Exploratory analysis in the determination of patterns. Please proceed, ma'am.
All right, thank you. For explanatory analysis, okay, that's talking about the MIST method design. Is that a question? I don't know. So if it's that, if the question is
the person is asking for, I think, clarification or more detailed understanding.
All right, thank you. So for the MIST method design, where we have quantitative and qualitative research method. Okay, so the explanatory, I said that we have two phases, can be two-phase design or three-phase design. So the explanatory sequential is usually sequential. Either the qualitative comes before the quantitative, or the qualitative comes after the quantitative. The beautiful thing about this mixed method design is to have an in-depth insight about what you're trying to study. So for the two phases where you have the quantitative data collection and analysis first, so you identify results for follow-up. So the results identified now will help to design your qualitative the data collection, and then you analyze. So you now interpret the results on how the qualitative explains the quantitative. You've collected your quantitative data, you've analyzed, you've identified some results. So it will help you in designing your qualitative now, questions to ask, type of interviews to carry out. Yeah, so now you would now be able to interpret both the results. Whether the qualitative, giving more deeper insight in what the results you have from your quantitative research method. For the three phase, you have the qualitative data collection and analysis first. You identify some features for testing, especially if you're trying to develop a new instruments or experimental activities. Then you go ahead, you do your quantitative data collection, then you interpret the results. So this shows how your quantitative improves the qualitative results. So that's why it's sequential. So it can either come before, after, or even while you're collecting the quantitative data, quantitative data. Thank you, and I hope I'm able to answer that question.
Yes, I think you have. Okay, do we have any other question before we call it a day? Okay, I think there is none. Yes, we'll get the recording. We'll get the link to the recording. It will be shared with us later today. We'll communicate that via mail. Yes, okay. Seems there is no other question. So this webinar has been organized by Plus-Circle Community Health Advancement Organization. So we implore you to please follow us on our social media platforms. We also have a phone number which you can call for any support, or you could reach out to us via WhatsApp. Okay, yes, so I want to appreciate Dr. Karim for the amazing presentation. She's a true example of beauty with brains. Yeah, so everyone on the call, I want us to show our appreciation to her for taking us through this exciting session. Please, let's use the reaction icon as we send
Thank you very much.
a token of our love. Thank you so much, Dr. Karim. It's been a pleasure having you on this call. You've been amazing, and you've amazingly delivered on this task. We are grateful for the time that you have been able to spend with us. Thank you for your commitment. Thank you for your investment. Thank you, and thank you. So, dear colleagues, if you have any question, you can still reach out to us via mail. The questions, you receive timely response to all your questions. And if you need any other research support, we are just a mail or a phone call away. So please, or a WhatsApp chat away. So please feel free to reach out to us for any support whatsoever. Okay, so it's been a good time so far this early Saturday morning, and I hope that you got value for the time you spent here just like I did. Next week Saturday would be another exciting session. Please let's invite our friends so that the knowledge we gain is disseminated and shared across our team. Together, every one of us can achieve more. We appreciate you for your time, and we look forward to your participation subsequently. We'll be having another wrap of capacity building session next week on abstract writing, and we'll be doing some reviews of abstract. So tell a friend to tell a friend to tell a friend so that we can objectively know or learn how to review our abstracts and how to tailor our abstracts accordingly. Thank you very much, Dr. Karim. You can please take a quick look at the chat box. Everyone is appreciating you for
I appreciate it.
gratitude. Thank you
Thank
so
you very
much.
much.
Thank you
Thank
so
you.
much.
I'm
All
very
right,
so glad.
everyone.
Bye.
Please
Thank
enjoy the
you.
rest of the weekend. Have a good day. Bye.
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 Dr. K, thank you.
Thank you very much.
Okay,
you.
Madam Z, we will consider that a session on choosing a study design. That's well noted.
Our pleasure always. Thank you, ma.
Thank you, sir.